to class today, pre-calculus studs. Hope you guys are doing well. Welcome to class on Wednesday, hump day, middle day of the week. I hope this is a Wednesday. I hope you're not so far behind on your videos that you're listening to this on Saturday or something. That would not be good. Welcome to class today on Wednesday, and hope you're ready to learn some math. I hope the week's gone well so far. I haven't gotten any emails or phone calls lately, so if I can help you, remember I'm getting paid to be your teacher, so don't hesitate to call me. You're allowed to do that once per month. I'm kidding. You're welcome to do that as much as you need to. Okay, let's get down to business. There will be a test this Monday, so you're welcome to grace me with your presence this Monday. If you're not going to come, please let me know no later than Sunday, please. It's just being courteous. I appreciate it. And that means this Friday you'll have a review sheet. So you do not have to do the review sheet, but if you'll do it, you'll get 5 bonus points on your test on Monday. Stay on top of your integrity sheets. Like right now, your integrity sheet should be filled out every day that you do the homeworks. That way you don't have to continue to remember, all right, whether or not you've done the homework. And don't get behind in the videos. That's really, really, really going to not be a good thing if we get behind on the videos. Sorry to lag there. I'm looking out the window. It looks like my kids are fighting with the neighbor kids. So hold on one second here. See if I can pause this video. Okay, sorry about that. I am back. Looks like the mother came out and she took care of it, so I'll keep an eye on it. Okay, moving on. So stay on top of all of your things here. Now, I might be wrong. If I'm wrong, I'm sorry, but I don't think I've heard from one student yet in your quizzes. They were due Monday. Now, I'll admit, I've been really good all week on staying on top of emailing your parents when you don't turn them in. I've gotten behind this week, so I really need you to take the bull by the horns and contact me if you're done with your quiz, because I've not heard from anyone or gotten a quiz, and I need to let your parents know if you're not doing what you need to do, so I can help them help you. Okay. All right. That's it for the announcements. Let's roll. We're looking at something today called Radian Measurement. Radian Measurement. Now you're used to this type of measurement right here, degrees. We're going to look at something more than likely you've never had. Okay. And this is called Radian Measurement. It's lesson 5.4. And if you want to know the date is the 18th. If you're big on keeping track of that type of thing. All right, so let's jump right into this and see if we can't learn some things about radian measurement. Now, first of all, and you can write this down if you want to. You really don't need to. I'm just explaining what it is. It's another unit for measuring angles. For example, I could measure the distance to your house in miles, meters, feet, yards, whatever. There's different ways to measure the distance from my house to your house. Now, the distance wouldn't change just because I changed the different unit of measurement. And so it's the same thing with angles here. Whether I measure the angle in degrees or radians, it doesn't matter. The angle is still the same. We just have different numbers because we're using different units, okay? This new unit, like I've just said now, is called radians. This new unit is called radians. 5 radians, 4 radians, 3 radians, etc., okay? Let me explain on the next page where radian measurement comes from. So get ready to take some really good notes and be ready to be impressed with this awesome mathematics, okay? All right, here we go. Not sure what happened. That's not supposed to be next, and that's not good either. And so just be patient with your teacher as I stroll along here. All right, there we go. I think this, hold on one second. All right, there we go. Now let's continue on. Okay, I'm back now, guys. Sorry about that. Okay, let's take a look at radian measurement and where it comes from, okay? I would like you to take some notes on this. First of all, I want you to write in your notes, circumference of a circle equals 2 pi r. Write that down, please. Circumference of a circle equals 2 pi r, okay? Now I want you to draw a coordinate plane. Here's your y-axis. Here's your x-axis. Just draw a circle on there as neat as you can, and then draw a radius like I have right here, a radius of 1. So the length of that radius is 1, excuse me, whether it's inches, yards, feet, whatever, it's just 1, okay? Now, if the radius is 1, okay, based on the fact that radius is 1, in your notes, come up here to your formula, and where the radius is, I want you to substitute 1, there. So here's r, I substitute 1. Fair enough. 2 pi times 1 would be 2 pi. So whenever the radius of a circle is 1, then the circumference is 2 pi. I just proved that to you. Circumference of a circle is 2 pi r. Where the r is, I put a 1 because our radius is 1, and you come up with 2 pi. That means the length all the way around the entire circle is 2 pi when the radius is 1. Students, if you didn't understand that, please don't worry about it. I'm not going to test you on this, but still take some notes and listen. If I go around the whole circle, that's 2 pi. So in radian measurement, now if I've lost you, it's okay. Just listen and take notes because you're not responsible for this. I'm just trying to teach you where this comes from. If I do a complete circle in degrees, that's 360 degrees. Well, if I do a complete circle in radians, we call that 2 pi because radians is based on a measurement as if you had a radius of 1. So 360 degrees is the exact same thing as 2 pi radians. Whoa, Mr. Earhart. Now you could also, don't forget guys, pi is 3.14. So 2 times 3.14 is 6.28. So you could say one of two things. You could say 360 degrees equals 2 pi radians, or you could say 360 degrees equals 6.28 radians. Okay? Either one is acceptable. Now, which one's normal? This one's more normal here. We usually measure radians in terms of pi. Now, I want to appeal to your common sense. Can we do that, please? All right, good. Thank you. All right, somewhere down here in your notes, I want you to write 360 degrees equals 2 pi. That means one whole revolution is 2 pi. So I've got a question for you aeronautical engineers. If I go halfway around the circle, wouldn't that be just 1 pi? I mean, of course, think about it. If I go all the way around the circle, and that's 2 pi, then if I go around just half the circle, that's pi. So why did I show that to you? Because I want you to realize that if I were to go halfway around a circle, that's 180 degrees. So 180 degrees then would have to equal pi radians. So isn't that really cool? If I go halfway around the circle, it's 180 degrees or pi. Now, let's take this a step further. We'll see how smart you guys are. If I go halfway around the circle, that's pi. So if I cut that in half and I only go to here, wouldn't that be 1/2 pi? Sure it is. And 1/2 pi would simply be the same thing as pi over 2. That's the exact same thing. Okay, so I just want to show you here that if I go 90 degrees like this, that's the same thing as pi over 2. Now, if you're not understanding any of this, like, Mr. Aaron, I'm totally lost, that's okay. That's not a problem because you don't have to be able to explain this to me. But what you can do is you can memorize this, can you not? Sure you can. So I can say 90 degrees equals pi over 2. Sure. Now, how about this? How about if I went, that's 1/2 a pi, then another half, that's a whole, and then another half. So if I went here, that would be 270 degrees, 90, 90, 90. And then I would go 1/2 a pi, then I have another half, that's a whole, then another half, that'd be 1.5 pi. Before I get to 2 pi over here, if I went all the way to here, that would be 2 pi. But I didn't, I stopped right here. Now 1.5 pi would be the same thing as 3 over 2, wouldn't it? 3 over 2 pi? And 3 over 2 pi is simply the same thing as 3 pi over 2. Now again, if you didn't get all that, you can at least memorize this, can you not? You can memorize that 270 degrees equals 3 pi over 2. Very cool. Very cool. And then from there we can do all kind of springboarding things. Like, for example, I could cut this in half and I could say 45 degrees is pi over 4. Now you don't need to know that, but I'm just saying we can do all kinds of neat things with this. But the main thing you need to know are these four, I guess we'll call them main conversion points here we need to know. 360 degrees equals 2 pi radians, 180 degrees equals pi radians, 90 degrees equals pi over 2 radians, and 270 degrees equals 3 pi over 2 radians. You can memorize that, okay? Now let's really break down radians on the unit circle. I'm not going to make you write this down, okay? I'm not going to make you write this down, but at least look at it with me. Just look at it with me, okay? Here we go. Now, Remember how I said this was pi over 2 right here in the last slide? Well, what is pi over 2? Is it pi? I mean, what is pi? Isn't it 3.14? So if I had 3.14 divided by 2, that would be 1.57. Do you remember how I said if you went all the way to there, that would be pi? Let's look back a page right here. Remember I said if we went all the way to here, it would be pi? So what is pi? Isn't pi 3.14? So I put 3.14. You see, here's what I did. Back here 2 slides ago, what I did is I broke down radians for you in terms of what? In terms of pi. All of your radians had pi written. But also we can look at radians as decimal numbers. So instead of putting pi here, I put 3.14. Instead of putting 2 pi over here, I could take 2 times what? What's pi? 3.14. I could take 2 times 3.14 and get 6.28, same thing. So this is kind of a breakdown here for you just to look at of radians in decimal form. Like this would be about 22 degrees is 0.397, 45 degrees is about 0.785 radians, 90 degrees is approximately 1.57, and so on and so forth all the way around the circle. See this 4.71 right here? Remember in my other slide I had what right there? 3 pi over 2? Well, guess what? If you take 3 times 3.14 equals divided by 2 equals, you'll get 4.71. Same thing. So I just want to break down the radians for you in decimals going around the unit circle. Now the unit circle just simply means a circle that has a radius of what? Do you remember? A radius of 1. You do not need to write this down unless you want to. You do not need to memorize this. Okay, moving on. Now, guess what? In the end, if I have totally lost you with everything I just said, it's okay. Cool. Dude, we're all right. We're okay. Here's what you need to know. You can really just memorize. That's what I've been saying over and over. Okay? Just remember that you start here at 0 radians, go up to 90 degrees, that's pi over 2. Go to 180, that's called pi radians. Go to 270 degrees, that's 3 pi over 2 radians. Go 360 degrees, that would be 2 pi radians. And by the way, think about it. If you went around twice like that, well, that would be what radians? 4 pi. Makes sense to me. I went around twice, so 2 pi and 2 pi. All right? And that's mainly what you need to know. I'm going to teach you some conversion facts here in just a little bit, but that's pretty good right now. Now, you do need to know this. We're going to start converting in just a second, contain your excitement, degrees to radians and radians to degrees. So I'm giving you a formula. Write this down. When you convert from degrees to radians, simply multiply the degrees by pi over 180. I will show you how to do that. When you're converting from radians to degrees, notice we flip this, you simply multiply by 180 over pi. It's that simple, guys. It is that simple. So let's do it. I'm a big firm believer in going fast to the video. Those that are faster get it. Those that are slower can back it up and listen to it. And most of your practice I want to be done during homework. Now, let's start converting all these to degrees and radians. By the way, from now on, if you don't see a little circle like this, then it's not degrees. It's radians, okay? Okay, we have 4 degrees up here. 4 different degree measurements. Let's convert them to radians, all right? So I'm going to take this here, buy myself a little space, slide these way down yonder. All right, there we go. And now I'm going to get some space. All right, when converting from degrees to radians, you multiply by pi over 180. So I'm going to take 120 degrees right here, put it over 1, and multiply it by pi over 180. It's that easy, guys. It's that easy. Now, yes, I can do some cross-canceling, and if I do that correctly, I would get 60 goes into both of these, so 60 goes into this twice, and 60 goes into this 3. 2 times pi would be 2 pi, and 1 times 3 is 3. You just, I'm starting to water up and cry. You just converted your first degrees to radians. 120 degrees is the same thing as 2 pi over 3. That is so cool. Now, by the way, what if the book asks you to write it in decimal form? Okay, no problem. Take 2 times 3.14, so 2 times 3.14 equals, and then divide it by 3 equals, and you'll get 2.09 rounded. There you go. So there's both answers. Both of these are radians. One is a decimal form, and one is in terms of pi. That's pretty cool. Okay, let's convert this one over to radians. So we're taking it from degrees to radians. So 68 over 1 times pi over 180. You always multiply degrees by pi over 180. All right? And it should work. All right, let's see if we can't do some simplifying. It looks like 17, it's like 4 goes into both of these numbers. 4 would go into 68 17 times, and 4 would go into 180 45 times. There we go. So 17 times pi would be 17 pi, and 1 times 45 would be 45. There we go. You just converted 68 degrees to radians. Now what if I want it in decimal form? No problem. Take 17 times 3.14 equals, then divided by 45 equals, and you would get 1.19 rounded correctly. Both of those are the same answer. One is in terms of pi and one is in terms of degrees, or in terms of decimals, excuse me. All right, now let's go ahead and get us a little more space here. And let me do this. And my son just walked in the room, so I'm going to pause the video. Okay, I'm back, guys. So now let's change 310 degrees over to radians. So 310 degrees times pi over 180. You always use pi over 180 when you're converting degrees to radians. And let's see if we can't reduce or simplify these two numbers here. 10 goes into both of them. So 10 goes into 310 31 times. 10 goes into 180 18 times. 31 times pi would be 31 pi, and 1 times 18 would be 18. So 310 degrees would be this right here. And if you want it in decimal form, take 31 times 3.14 equals divided by 18 equals, and you'll get 5.41. So there you go. Both of those are radian measurement. Okay? All right, let's take a look at our very last degree. It looks a little intimidating. Let's see if we can't put a little reasoning to this. So we have negative 297.25 over 1 times pi over 180. Now, if we do that correctly, I'm going to go ahead and slide this down and give myself a little room. So let me go over this again. Anytime you're converting, are you getting this? Anytime you convert degrees to radians, you use pi over 180. So, you know, I've got a decimal right here, students. I'll tell you, I really don't want this in terms of pi. This is going to be a mess. So I'm going to go ahead and put a negative sign, because a negative times a positive is negative. I'm going to go ahead, I'm not going to try to simplify or reduce. I'm going to take 297.25 times 3.14. And if I do that, I'm going to get 933.365 all over 1 times 180 is 180. And then go ahead and divide that out. So divided by 180, and we would get 5.19 rounded. So negative 5.19. So there, I did it again. I didn't write it in terms of pi because I already had a decimal. It'd be a little tough to do. It could have been done, but I just went ahead and converted it over in decimal form. So we took all these 4 degrees and we converted them over to radians. All right, let me do this real quick. There we go. There we go. All right, let's see if we can't get this here. All right, now let's go ahead and let's take some radian measurement, and let's see if we can't convert that over to degrees. Now look at the sentence here. When converting radians to degrees, you multiply by this. So let's give it a shot. We have 3 pi over 4. I want to convert that to degrees, so times 180 over pi. Now first of all, your pi's cancel, so cross off your pi's. Next, 4 goes into 4 and 180. 4 goes into 4 once, and 4 would go into this 45 times. And now we simply have 3 times 45. That would be 135 over 1. 1 times 1 is 1, so 135. There, you did it. You just took a radian measurement and converted it over to degrees. I think that's pretty easy. All right? All right, let's go ahead and take a look at the next one. 8.5 radians. Let me get an eraser here. It'll be a little faster, I believe. All right, let's take a look now at 8.5 radians. And let's convert that over to degrees. So don't freak out. There's no pi in here. That's okay. And by the way, this was supposed to be 6 pi. Let me look at my notes here. This is supposed to be negative. Yeah, I'm going to change that later. That's not correct. But anyways, we'll get to this when we get to that. But there's no pi with 8.5. Don't worry about that. It's still 8.5 over 1 times 180 over pi. No big deal. So we simply multiply across, take your calculator, 8.5 times 180. So 8.5 times 180 would give you 1,530. 1,530 over pi. And now divide that out. So 1530 divided by 3.14, and you will get 487.26 degrees. 487.26 degrees. So there, radians here is the same as this degrees here. Piece of cake, guys. It's really, all the stuff I taught you at the beginning, I just wanted you to be familiar with it. If you didn't get that, you can at least learn how to do these problems, okay? All right, let's convert 37.12 radians to degrees. We're going to multiply it by 180 over pi. So first of all, we take 37.12 and we multiply that times 180, and we get 6,681.6 all over 1 times pi, which of course is pi. So now we take 6681.6 divided by 3.14, and we're going to get 2,000, well, that's a lot, 2,127.9 degrees. So 37.12 radians equals this in degrees right here. So again, pretty cool stuff. You're learning how to convert degrees to radians and radians to degrees. Now, I'm going to change this here. This is not what I originally wanted. I wanted 7 pi over 6. There. Okay, let's take 7 pi over 6, and let's convert that to degrees by multiplying by 180 over pi. Now again, your pi's would cancel. 6 goes into both of these numbers. 6 goes into 6 once. 6 goes into 180 30 times. And then 7 times 30 is 210 degrees. Of course, it'd be 1 times 1 is 1, so 210 over 1 would just be 210 degrees. So 7 pi over 6 is in radians is the same thing as 210 degrees in degrees, okay? All right, very good. So you just learned how to do a bunch of conversions. Very cool. So you now should be able to convert from degrees to radians and radians to degrees. All right, let's start playing around with radian measurement. Let's just get used to them, okay? I'm sure that really gets you excited there. All right, let's talk about finding the complement, okay? Let's find the complement of these two angles using radians, not angles. Now, would you think about that for a second? Look, guys, if I said find the complement of 60 degrees, you know what you would do. Complement means the two angles add up to 90, so you would immediately take 90 and you would subtract 60 from it, and you would get 30. And then you would say the complement of 60 is 30. And you got that so easily because you simply took the given angle and you took 90 minus that given angle, right? Sure, you guys know how to do that. So would it not be the same thing in radians? If I want you to find the complement of this angle that's in radian form, I would just take 90 and subtract pi over 6. I should have done this down here, excuse me. Well, I officially give up. Anyways, I'm going to copy this down here. You would simply take 90 minus pi over 6. But hold it, 90 is in degrees. Let's go back quite a few slides. Do you remember what 90 degrees is? Oh, there it is. Right there. Remember 90 degrees is pi over 2? Remember I gave that to you right here? Right here? So if I know that 90 degrees is pi over 2, then instead of using 90 right here, I'm going to use pi over 2, same thing as 90, minus pi over 6. Now, look, pi over 2 is just the same thing as 1/2. And pi over 6 the same thing as 1/6, as long as you put pi back in your final answer. So 1/2 minus 1/6. Now use your graphing calculators. And for some of you that don't have one, you should have a fraction button on your calculator. If you don't, I really can't help you. But for those that have a grapher, unless you call me and ask me, and I will help you try to find it. But those that have a grapher, you would type in 1 divided by 2 minus 1 divided by 6, enter, and then hit math, enter, enter. Look at the left side of your calculator, third button down, you'll see a math button. Hit math, enter, enter, and if you do that correctly, you should get 0.333333. Then hit math, enter, enter, you'll get 1/3. Okay, so 1/2 minus 1/6 is 1/3, and then go ahead and put your pi back up top. And what is 1 pi over 3? Isn't that just pi over 3. Sure it is. So you did it. You took 90 minus pi over 6, did all the math, and you got pi over 3. So what's the complement of pi over 6? Pi over 3. If you add these two together, you'll get pi over 2, which is 90 degrees. So there, we did it. All right, let's try another one. Let's try 2 pi over 5. Now, I want you to find the complement of this angle. So we're going to take 90 minus this angle. But of course, this is in radians, so we want this to be in radians. So 90 is the same thing as pi over 2. So pi over 2 minus 2 pi over 5. Now, it's a little easier just to use the fractions 1/2 minus 2/5. So with your calculator, now if you want to get a common denominator and do all that work, it would be 5/10 minus 4/10. That's fine. And you'll get 1/10. But if you also use your graphing calculator, 1 divided by 2 minus 2 divided by 5, you'll get 1/10 if you hit math, enter, enter. So 1/10 is the right answer, but don't forget to put pi with it. And of course, 1 pi over 10 is just pi over 10. And that's the way you really should write your answer, pi over 10. So what is the complement of 2 pi over 5? Pi over 10. And if you add those two together, you would get pi over 2, 90 degrees. Very cool. So we're just playing around with radians, much to your enjoyment, I'm sure. All right, let's try find the supplement. Let's find the supplement of these angles. Now look, guys, if I said find the supplement of 120 degrees, you know supplement means the two angles have to add up to 180. So I think most of you know you would take 180 degrees and you would subtract the given angle, which is 120, and you would get 60 degrees because 60 plus 120 is 108. So the complement of 120 would be 60. So what you do when you're asked to find the supplement of an angle, you take 180 and subtract the given angle. Well, let's just apply that to this problem here. Let's do the exact same thing. Let's find the supplement of pi over 6. Now, if we're going to find the supplement, that means we have to take 180 degrees minus pi over 6. Hold it, though. I don't want to use degree and radians. Let's go back about 4 or 5 slides. Do you remember what 180 degrees was right here? Remember, it's pi. You go around the circle halfway like that, and 180 degrees is pi. So we're going to use pi instead of 180 degrees. So here's 180. I'm going to use pi minus pi over 6. Now pi is just 1 because there's a 1 in front of it, so we're just going to say 1 minus 1/6. Now 1 minus 1/6 is 5/6. And then of course don't forget to put your pi back up top. So pi minus pi over 6 is 5 pi 6. So what's the supplement of pi over 6? The supplement of pi over 6 is 5 pi over 6. There it is. And if you were to add these two together, you would get 180 degrees, or you would get pi, which is 180 degrees. All right, let's find the supplement of this angle here. So remember, what we're going to do, let's slide this over and create a little space, like I always jokingly say, like a soccer player. All right, now let's take 180 degrees and let's minus this measurement. Well, 180 degrees is pi, so pi minus 2 pi over 5. Now, of course, there's a 1 in front of pi, so I'm just going to say 1 minus 2/5. Now, 1 minus 2/5, as you should know, is 3/5. And if you don't know, just use your calculator. You'll get 3/5. And don't forget to put the pi back up top. So pi minus 2 pi over 5 is 3 pi over 5. So what is the supplement of this angle right here? The supplement is 3 pi over 5. And by the way, if you were to add these two together, you would get 180 degrees, or you would get pi, which is the same thing as 180 degrees. Cool, cool. Almost, I think we're almost done. Yeah, this is it. We're almost done, guys. Now I want you to quickly play around some more with radians. I want you to find a positive and negative coterminal angle. Now don't freak out over this. Let me help you, okay? That's what I'm here for. Let's go ahead and start with 2 pi over 3. Let's draw a coordinate plane so we can get a picture of it. And let's hopefully your coordinate plane looks better than that. Better than mine. Let's draw 2 pi over 3. Now we know this is pi over 2, which is 1/2 pi. So we know we're going to have to go past that because we're 2/3 pi. And this is pi right here. So if we go here, that's only half a pi. So we go a little further. I don't care how far. It's not really a big deal. And we draw our angle. So from here to here is what? 2 pi over 3. Now, do you remember how to find a coterminal angle? Remember, we start here and we go around once And then that'd be how much right there? We went around once. That's how many radians, remember? 2 pi. And then we go to the terminal side. That would be how much more? 2 pi over 3. So we're going to add 2 pi over 3. Well, 2 pi, we're just going to say 2 plus 2/3. 2 plus 2/3 is the same thing as 2 and 2/3. 2 and 2/3 is the same thing as 8/3 pi. Put the pi back up top, of course, when you're done. So there, you found a positive coterminal angle, 8 pi over 3. Now I'm going to use green. Hopefully that'll stick out. Now we're going to find a negative coterminal angle. So I start here, and I go down and around until I hit the terminal side. Boom, I hit the terminal side right there, right? Sure. Now, I did not go all the way around. If I would have gone all the way around, that would have been 2 pi. But I didn't go all the way around, so I got to subtract something out. Notice the space that I didn't go from here to here would be 2 pi over 3. Do you see that? Here's that space right here. 2 pi over 3. So since I didn't go all the way around would have been 2 pi. I stopped here. I've got to subtract out the part that I did not go around. So 2 pi minus 2 pi over 3. All right? And that should give me my negative angle because I went down and around. So 2 minus 2/3 would be 1 1/3, which is 4/3. Put your pi up top. Now hold it. We went down and around, so it's a negative 4 pi over 3. Okay, hope you're getting this. One more example and the video's finally over. So you've been troopers. Good job sitting there listening to everything so far. Hopefully I've not put you to sleep too badly. Let's go ahead now in your notes. Last problem, we're finally done. Let's go ahead and find a positive and a negative coterminal angles for 7 pi over 4. So let's go ahead and draw our coordinate plane. Now, think about this, guys. 7 pi over 4 would be like 7 over, what is 7 over 4? Isn't 7 over 4 1 3/4? So it's the same thing as 1 3/4 pi. And the reason that's important is you got to realize, here's pi right over here. So we go to here, that's pi, and then we have to go 3/4 more, okay? So be careful here. We know here it's 3 pi over 2, right? Or in other words, what's 3 pi over 2? Come on, guys. 3 pi over 2 is 1 1/2 pi. Where am I getting all this from? Let's go back. Let's go back. Okay, I told you didn't have to understand this, but you had to memorize this. This is 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, 2 pi radians, okay? So right here is where we're at, and that's 3 pi over 2. Now, 3 over 2 is 1 1/2. So if we go to here, that's 1 pi. If we go to here, that's 1 1/2. Guys, we got to go to 1 3/4. We got to go a little further. So we'll go about right there, and we'll stop. Okay? So we went all the way around to 1 3/4. Now, if I would have gone all the way around, that was what? 2 pi? So if I stopped here, now come on, think, guys. If I went all the way around to here, that's 1 3/4 pi, or in other words, 7 pi over 4. So I'm going to go ahead and put 7 pi over 4 is what went all the way around. Okay? Now, I've drawn the angle. Now let's find a positive coterminal angle. Remember how to do this? Positive coterminal angle. So we start here, and we have to go around once, because we can't stop here. That'd be the same thing we have. That'd be 7 pi over 4. So we go around once, and that's how much? 2 pi. And then we go around again until we hit the terminal side. Now we went around once, that's 2 pi, and then from here to here, that's going to be 7 pi over 4, which is the angle we already measured. So it's 2 pi plus 7 pi over 4. Let's go over it again. I went around once, that's 2 pi, and then from here to here would be 7 pi over 4. That's the first angle that I drew. So I really have 2 plus, what is 7/4? 1 3/4. So I have 2 plus 1 3/4. That would be 3 3/4. That would be 15 over 4 pi. So there we go. And there's one coterminal angle, 15 pi over 4. Now let's find the negative coterminal angle, negative. So we start here and we go until we hit the terminal side. Boom. That was easy. My goodness, that was a piece of cake. Now think about it, guys. Do you see this terminal side right here? Really give me your brains. I'm almost done. If we start it here like we did and go to here, that's 7 pi over 4. We already said that. Or in other words, what is 7 pi over 4? 1 3/4 pi. So if we go from here to here, that's 1 3/4 pi. So if I'm going to go with this little bit of remainder here to give me 2 pi, what would that have to be? If I went 1 3/4, then I have to go how much more? 1/4. So this little space here is 1/4 pi. Think about it. From here to here is 1 3/4. So I go 1/4 more, and that gives me 2 pi. So when I rotate down, the measurement of this angle right here is 1/4 pi, or in other words, pi over 4. Now I did rotate down, so that's negative. So a negative coterminal angle for 7 pi over 4 would be negative pi over 4. Booyah. Now this is not easy, but you've got homework to work on, and you've got a help video to help you. Now, you've been troopers. Thanks for listening. Good job. Now watch this carefully. I need you to do these problems in your homework, but I'm going to give you a heads up. You don't have to do number 7, to which I can hear the cheers all the way to my house from, what's Matthew Street, Morris Hill, I think, or and Corey lives further away. I can hear Corey cheering all the way to my house. You don't have to do number 7, but what I do mandate, as this is mandatory, is you watch the video and watch me do number 7. Just watch it. That's all I want you to do is watch it and learn. Watch me do number 7. You don't have to do it, and then do the rest of them 9 through 57 odd. Okay? Have a great Wednesday, guys. Keep working. Call me or email me if you have any questions.